Good evening. This is a problem on physics. In this YouTube channel, we are uploading, at present, we are uploading videos on mathematics, lectures on mathematics, okay? But later, in near future, we will simultaneously upload videos on physics also. And here, already I have uploaded three lectures on physics, mostly from mechanics. Here also I am going to start one more topic on the same thing, that is mechanics. Here it is statics. The previous three ones were on dynamics, and this is on this is also on dynamics, not statics. Sorry, I'm extremely sorry. This is motion along inclined plane. Motion along inclined plane without friction. Without friction. So this is the topic. Okay. Motion along inclined plane without friction. We know that when two objects touch each other, there must be some friction. There must be some friction, whatever small it may be, but there must be some friction. But for the sake of simplicity, in engineering as well as in science, for few problems, we will simply assume that there is no friction. So if there is no friction, that means frictional force will be absent in the mathematical analysis of the given problem. So suppose we have an inclined plane. You know that thing. If you are a student of class 11, science stream, then you know that what is inclined plane. This thing, now this thing is horizontal, okay? This thing is horizontal. This packet is horizontal. If you keep this way, then this is inclined plane. This becomes inclined plane. Okay? If you keep this way. This is upslope. When you are going from here to here, then it is upslope. When you are going from here to here, then it is downslope. Downslope, upslope. Okay? So we know that if you walk from here to here, you will face difficulties. You have to consume more energy to go from here to here. But when you are going from here to here, requirement of your energy will be less. You have this much of experience, I think. So here also same thing. This is parallel to this. This is parallel to this. Okay? So this is the inclined plane. So if you keep one object here, suppose this one, if you keep one object here, so it will slide down the inclined plane. Okay? If friction is present, then there is a chance that the object stands there. It does not move. Okay? But if friction is absent, then it must move. The object, if you keep the object somewhere here, then it must move along the inclined plane. If inclined plane was absent, what would happen in that case? If inclined plane was absent, and suppose you have kept one object here, somewhere here, if you keep one object, and if you now remove the inclined plane, then the object will go in the vertically downward direction. It will move in the vertically downward direction if you remove the inclined plane. But due to the presence of the inclined plane, it is not possible for this object to move in the downward direction. It will move along the inclined plane. Okay, this way. So, and one more thing you have noticed is that it is not rolling. There is a chance that it rolls while it is going in the downward direction along the inclined plane. But our assumption for this problem is that it is not rolling. It is just sliding down. Okay, along the inclined plane. And here in this problem, friction is absent, so there will be no frictional force acting on this object. So suppose this point denotes the center of gravity, that is CG, center of gravity of this object. So if you do the free body diagram, if you draw the free body diagram of this object, what will happen? What are the forces which will be acting on this object? First, I am showing here, okay, I am not drawing separately, I am showing all the forces here. This force which will be acting in the vertically downward direction, that is equal to weight of the object. Suppose mass of the object is m, then what is the weight of the object? Mass multiplied by acceleration due to gravity. That becomes the weight. So weight will be acting in the vertically downward direction, which is equal to mg. This is the weight. Now, and one more force will be acting on the contact surface. At the contact surface, there will be one normal reaction acting on this object. That normal reaction will be exerted by the inclined plane on this object, and that force also will pass through the center of gravity of this object. So one force will be acting in this direction. This is what? This is the normal reaction, R. Okay? Exerted by this inclined plane on this object. This is normal reaction R. Now, so this line which represents normal reaction, this is perpendicular to this inclined plane. Now, for the sake of analysis, we need to resolve these forces into two components. So it is better for this problem if you resolve this weight into two components, one along the inclined plane and another along the another perpendicular to the inclined plane. So if you draw a parallel line, suppose this one, okay, and suppose inclination of this inclined plane is theta, means this angle which the inclined plane makes with the horizontal is theta. You assume this thing, okay. Without specifying this theta, the inclined plane cannot be defined, okay, without specifying theta. Theta is very important. So theta, if this is theta, then we need to know all these angles. What will be this angle? Can you tell me? What will be this angle? If you extend this, okay, then since this is theta, if you extend this is vertical line, this is horizontal, so this angle is 90 degree. That means this angle is how much? This angle is 90 degree minus theta. Right? Then this is what? 90 degree minus theta. This angle is 90 degree minus theta. Okay? This angle. So since this angle is theta and this line are parallel, therefore this angle is also 90 degree minus theta. Right? This angle is also 90 degree minus theta. So I am writing here 90 degree minus theta, this angle, this is degree, okay? 90 degree minus theta. Right? So this angle is 90 degree minus theta. Now I am using another color. You extend this line. So what? So since this is 90 degree minus theta, so this angle is how much? This angle is theta. Okay. It is very, very easier to get the angles, required angles. Okay. So this is the force mg. This vertical one is what? This is mg. This angle is theta. So what is the component of mg in this direction? It is nothing but mg cos theta. Am I right? Since this angle is theta, so these components should be mg cos theta and this component should be what? This component should be mg sin theta. Mg sin theta is this component. The body means this object is moving along the inclined plane. So which force we should consider? We should consider this force. The body is moving under the action of this force. When the body falls freely, then the body moves under the action of force, only weight mg, not mg sin theta. Okay, only mg. And if you want to use the angle theta, in that case theta becomes 90 degree and nothing else. 90 degree. And sin 90 degree is one that is known to you. So this moves along this direction. Okay, under this force, under the application of the force mg sin theta. And this is normal reaction. This is. So we can easily write that this force R and this mg cos theta are opposite to each other. Okay, they are opposite to each other. Therefore, we can write R is equal to mg cos theta. So this is the amount of normal reaction exerted by the inclined plane on the body, on the object R. And if theta is equal to 0 degree, what is the meaning of theta is equal to 0 degree? If theta is equal to 0 degree, that means the inclined plane is no more inclined, it is a horizontal plane. And in that case, theta will be equal to 0 degree. So cos 0 is equal to what? Cos 0 is equal to 1. And in that case, normal reaction becomes equal to mg. That is known to you. Normal reaction is equal to weight of the body itself. When theta is equal to 0 degree, that means inclined plane remains no more inclined. It becomes now, when theta is 0 degree, it becomes now horizontal plane. So in that case, R becomes equal to mg. But our requirement is to get the result in terms of theta. Means we are assuming that the plane is still inclined. Okay. Theta varies from 0 to 90 degree. So R is equal to mg. So if you are asked to calculate a normal reaction, then using this formula, you can calculate normal reaction, where m is the mass of the body, means object, this object. G is the acceleration due to gravity, which is 9.81 meter per second square, and theta is, it is cos theta. Theta is the inclination of the inclined plane. And under this, you can see there is no opposing force. There is no opposing force. So the body moves under the action of only this force, mg sin theta. This is the net resultant force along the inclined plane. Net resultant force along the inclined plane, net force, net resultant force along the inclined plane is how much? This is equal to mg sin theta. Okay, this is the net resultant force along the inclined plane. So, if A be the acceleration, small a be the acceleration of this object, then this force is equal to, should be mass into acceleration according to Newton's second law of motion. Okay, force is equal to mass into acceleration when mass remains fixed or constant. Here mass is constant, it is not changing. So we can write that, so using this principle, what is the principle? Force is equal to mass into acceleration. Okay, acceleration. So from here we can write force is how much? This is mg sin theta. Mass is how much? M. Acceleration A. Therefore, from both sides m are cancelled. Therefore, we are getting what? We are getting A is equal to g sin theta. A is equal to g sin theta. This we have got. So acceleration of the object is equal to g sin theta. Let me check whether lower portion of the board is visible or not. There is no helping hand here today, so I need to check myself. A is equal to g sin theta, right? You can see that here acceleration does not depend upon the mass of the object. Mass of the object was m, but in the formula, in the resulting equation for acceleration, in the resulting expression for acceleration, mass is absent. That means acceleration does not depend upon the mass, it depends upon only the angle theta. Theta is what? Theta is the inclination of the inclined plane. Okay, so acceleration is equal to g sine theta. And you know that when theta is less than 90 degrees, sine theta is less than 1. If sine theta is less than 1, then A becomes less than g. Am I right or not? When theta is in between 0 and 90 degree, in that case sine theta is less than 1, and since sine theta is less than 1, then in that case A is less than g. When the body falls freely in the vertically downward direction, in that case A is equal to g. You know that thing. A becomes equal to g. Okay. But when there is inclined plane and if friction is absent, in that case acceleration is reduced by a factor sine theta. Okay. By a factor sine theta. If theta is equal to 30 degree, if theta is equal to 30 degree, in that case sine theta is equal to what? Sine 30 degree is equal to half, 0.5. So acceleration becomes just half of g. 9.81 by 2. 9.8 by 2, that is a 4.9 meter per second square. Okay, I am giving you this example here. When theta is equal to 30 degree, in that case A is equal to g into sine 30 degree is equal to 9.8 into half is equal to 4.9 meter per second square. Okay. And when theta is equal to 0 degree, in that case sine 0 is equal to 0, so A becomes equal to 0. That means we are talking about now horizontal plane. For horizontal plane theta is 0, so there will be no movement of the body by itself, okay, by its own weight. If you keep an object on a horizontal plane, in that case there will be no movement of the body due to its own weight. Okay, whether friction is present or not, but there will be no movement unless and otherwise you are if the object is pushed by some other force, by some external force. So this was all about the topic motion along inclined plane without friction. In the next video lecture, I'll show you motion along inclined plane when friction is present. Okay. Okay, so this is the end of this lecture, and thank you.